Hello, my name's Brad. I'm an engineer with the Canada Masonry Design Center, and today I'm doing a quick little demonstration just showing you the basics of doing a multi-story shear wall. So to get started, when you open up the mass welcome screen, you'll see multi-story shear wall here, and so you can click on that and it will start getting that ready for you. Alternatively, if you already have a file or a project started, what you can do is click on the Add button and select multi-story from this part as well. So when you're here, if you're familiar with the regular shear wall element or even the shear line module, then this shouldn't be too big of a departure for you. You start by putting in a length. I'm just going to put in 4 meters here. All of the dimensions put in millimeters, and just for a height, I am going to do a height of 16 meters. Keep these numbers fairly round. By default, you'll see it shows the entire wall as just one story, and so I can split that up. So let's say if it's a 4 or 5 story structure, I can do it that way, and you'll see by default it just evenly spreads them out. Now if I wanted to, I could click on the floor layout tab, and you'll see these auto check boxes are selected by default, and so what that means is that it will just automatically space the floors evenly. But if you wanted to move one of these floors, or if you had some stories that are different heights than others, then you could adjust that here as well. Basically just changing the elevation location that shows up there. So going back to our main area here in our materials tab, another thing to point out is that we have different groups that you can bundle these properties into. So by default, the entire shear wall will be designed using the same block strength, size, vertical and horizontal rebar patterns and layouts, unless you wanted to break that up and split that up. So what you can do is create another group if you wanted to have two different ones. So it's called Group B by default. And so now we have two different selections. So if I, for example, knew that for Group A I did not want to use certain sizes, I can make those changes, and then Group B still has what was there before. And so I'm just going to leave these here as the default for now. But you'll notice when you look at the drawing, everything is still using Group A, and that is because it is not yet assigned. So what I can do is click on the Assign Groups tab, and you'll see I have a column for each group. And so if I wanted to use Group A for maybe the top 3 stories, and then Group B for the bottom 2, I could do it that way, or I can change that any way I like. But by default, everything will be designed using the same block size and strength. You'll notice that there's a plastic hinge group that shows up here as well, but these aren't available to be clicked on. And same goes for here. There's a plastic hinge group that can't be deleted. That always appears in the groups. Now, even if you're in an area of very low seismic risk, there's no way to get rid of that. However, it won't actually get used unless you need it. So for example, if you are not designing a structure that is moderately ductile or ductile using the building code SFRS classifications, then in those cases, whatever you put in the plastic hinge, it isn't going to matter because it's not actually being used anywhere within the wall. So I'm going to move to looking at the load screen now. So you'll notice what is new is that there's a pre-laid out table here. So you can simply go through here and put in whatever numbers you like. So these are total forces that are applied at each, basically at the top of each shear wall element. So there's no option to apply like a UDL, but it's pretty common just to basically simplify it where we lump those forces in coming into the top of each floor. So I'm going to do the same thing here for earthquake forces. Mind you, the forces that are calculated, these are unfactored loads, but they also take into account an RD value that is put in here. So conventional construction, you'd use 1.5. Moderately ductile, you would use 2, and ductile, you use 3. And then anything unreinforced, you have no ductility. And so your RO and your RD factor would be 1. I can do the same thing for vertical loads here. I'm just going to, just for demonstration's sake, put 50 kilonewtons there. I'll put some live loads on the rest of these. You'll see as I put these in. I can just use the arrow keys to move around too, which is fairly handy. And I'm going to put a snow load at the top here of 45 as well. So you see all my loads are applied here. If I had a different load type that I needed to apply, or if I wanted to separate them, you'll see there's an add load buttons that appear here. So if I click on that, basically what I can do is I can choose a different load type and I can apply them. But I don't have anything there right now. And even if I were to leave this here, there are no actual loads added, so nothing would happen, but I'm just going to remove that. So since I have earthquake loads that are applied, you see into the seismic column there, if I click on the seismic tab, I actually need to fill these in as well for it to perform a design. So there are two different methods here. We have a simplified and an equivalent static force procedure, both from the building code. So I'm just going to put in some seismic hazard index values here and a period. I'm just going to put 0.4. And so in these cases, so now I've populated this, you'll probably know that, especially for the seismic hazard index of 0.2 seconds, really 0.35 is the magic number, where as soon as you're above that, you start triggering a number of other checks. And so I'm just going to choose a number that's slightly above that. So now that I have these, I have everything else. So what I'll do is I'll click on the design button. And now what's happening is the software is going through. It's going top to bottom, first designing for capacity. Then it's getting all the groups to use the same properties. So now it's designing the bottom story. And then after it does that, it gets them all so that they're using the same property, updating all the self-weights and everything. And then it has to, once they're all the same, it has to go through calculate drift, and then it will go through and do a PM diagram. Then the last stage, it kind of freezes for a minute because basically what's happening is it's creating all the tabs that you would see appear, one for each of these 5 stories. So here are our results. You'll see it's giving me a 15 centimeter unit, 30 MPa block, and has a bar, a vertical bar cell. I can scroll up here. You see I have heavy duty joint reinforcement between every single course as well. And if I click on my PM diagram, you'll notice that I have this line that is drawn here. So for conventional construction, for any of the earthquake load cases, you can't be above this point. So sometimes you do see points that are above that. That's just because that is a load combination that does not have an earthquake load applied. So sometimes what you can do is if you want to change your design partway through, you can go ahead and do that. The other thing just to keep in mind, though, is that when you have a design that has a bar every single cell, especially in this case, chances are, since the default selection for the grouting pattern is partially grouted, then it's probably at putting a bar every single cell, not because it necessarily needs the 15M bar in every cell, but actually just because it needs the grout. So if I change that to fully grouted, let's just see how our results change here when we go through. So wait for it to go through and design again. Another thing I'll point out is that we did create a group B, but it's actually not being used anywhere. So we're going to come up with a design that we'll see for the entire height of the structure. But what we can do, you'll see, I'll wait to see how our results differ. Maybe they'll be exactly the same. Maybe we did need all that steel. We'll just wait for it to load here. It's generating all the results. Just have to wait for a minute while it does this. Here we go. Okay, so now you'll see these designs are a little bit different. Now we have the same block size and strength, only now we're fully grouted, and you can see instead of having a vertical 15 bar every cell, we have 25s spaced at 800. Whether or not that's better or not, I mean, it's significantly less rebar, but those bars are a lot bigger, longer development lengths and things like that that are not checked within the software. But there definitely is a difference there. Now, one other thing I mentioned that just to see and to demonstrate how you can mix different properties. So we do have this whole option for group B properties here. I'm going to start I'm just going to make group A at least a 20 centimeter block, and then at the assigned groups, what I'm going to do is I'm going to make the top 3 stories group B. You'll notice I can go through and I can just make changes here, and it interrupts the process and starts it again. So don't feel like you need to wait for the entire design cycle to complete before you make any changes that you might be interested in seeing. So now we're going through, you'll see, well, we'll see what happens here with our results. Fun part of waiting to see our results populated here. Okay, so now if we take a look, we have bars at 1.2 meters down at the bottom with that 20 centimeter block, and then we have bars every single cell in group B up here at the top. If we look at the PM diagram, now I'm guessing that maximum stress for conventional construction is coming into play here as well. And so also for group B, just because of my loads, if I switch this to fully grouted, and then even for group A, I had a lot of steel grouped in the middle, so maybe I'll turn off the 1000 and the 1200 spacings, just because it seemed like there was a nice even bar distribution when we had that 800 design before. So now we'll just wait for this design to go through and complete. It's equalizing the groups, checking drift and everything. And now we'll just wait for the results and to see how things differ. Like I said, maybe they won't be too different, but let's just wait and see. Okay, so you'll see we have it's summarized here in the results area as well as in the drawing. And so being fully grouted, now you can see we're no longer putting bars every cell. Once again, since we selected the fully grouted selection, we have that. We have one other thing, maybe one other quick change that I'll make is we have heavy duty joint reinforcement every cell in both groups A and group B. And so what I'm going to do is I'm actually going to just turn off the joint reinforcement for group A, and I'm going to do the same for group B by just turning off that option. So all we have is the none selection that's available. And what that will do is the software will place bond beams instead. And actually, since they're 3-meter stories, I'm going to interrupt this again. Just because, as if this, oh, we're generating the results. Hold on. Let's see, yeah, so I turned off that option. I'm going to do it again. Just because this video wasn't long enough, I'll do it for both so we get a nice 3-meter spacing for these bond beams at the very furthest. So let's see what we end up with. So it's going through, deflection, okay, now it's just generating the results. In a lot of cases, this is what takes the longest. Between that and the PM diagrams, if you have a wall that's very long, then the PM diagrams can take a very long time to do, just because you have so many coupling forces that are dealt with. Here we go. So now, just to summarize, you can see we have bond beams, 15M in both cases at 1 meter along the full height, and then it goes from a 15 centimeter, 15 MPa for the top 3 stories up to a 20 centimeter, 20 MPa in these bottom stories. Just to quickly point out, we are checking interstory drift now, so you can look at the deflection tab. You can see these numbers, and same within the drawing. These are very exaggerated. I can zoom in here. But the interstory drift is about, in this case, about only 20% of what the maximum is. And with masonry structures, it's very, I find, at least in my testing, that it is fairly difficult to have issues with the drift limits without also having not meeting capacity, shear, or other maybe other seismic restrictions as well. Another thing to point out is that we do have a seismic tab where we summarize these results saying what method was used. We check irregularities if they are required, but you'll see there were no errors, and that's just because we're not post-disaster. There are some other limitations in the building code that the software checks against. And for a ductility verification, this is conventional construction, so we did not perform one. But in the seismic tab, had I selected a different ductility level, then that may have been required. And I think that pretty much sums it up. The only other thing I'll point out is that all of the results are available for each of the 5 stories, because this is basically just an overview. All of the actual analysis and design is still done within our shear element modules. This multi-story interface is meant to speed that up and coordinate those designs just to save the designer time when going through and doing it yourself. So if I go through, for example, story 1, that's going to be our critical story. So you click here, everything is disabled. You can't actually make changes from in here, but you can go through and see what exactly is going on in the story. You can see all the different forces and things. You can look at the interaction diagram and actually select the different points that are here. If I zoom in here, you'll notice that of all the load combinations that have an earthquake load, mainly 12 and 15, I believe, are the ones where you would have that issue. If I go to simplified shear wall properties, I can look at all of these different load combinations. So load combination 12 is the one that I found in my testing. Usually can cause the most trouble just because it's your 1.0D plus your 1.0 earthquake load, but you also have those companion loads, so half of your live load plus a quarter of your snow load that's on there. And then load combo 5, just a little bit further up here, that's just your basic 1.0D and 1.0E. And then other than that, I mean, you can look at the shear results and everything for each of these. But going back to the multi-story, we also show that now for the entire height. So you'll notice a lot of sort of funky patterns with the way that it steps in or out. That's just a function of our shear strength equations. We're just following what's in the CSA standards and trying to do that just on your behalf as the designer. And you'll see for in-plane shear in this case, mostly because we switched to being fully grouted. We do have plenty of capacity there. If you have any other questions or about anything else that is new with Mass version 4, there are a number of other videos. I mean, on this website, you can find a lot more articles, hopefully answering your questions. But we also just want to encourage you to reach out to Mass Technical Support if you do have any other questions that come up. You can get in touch with us fairly easily. You can call the Canada Masonry Design Center. We're the authorized technical support provider of NMDP. That is the group that creates the Mass software. And so if you just go on the Mass website and follow the information on the contact page, then we just want to encourage you to send in your questions. And usually, I mean, you can spend all day hitting your head on your desk trying to figure out what's going on with your design, or it could just be a quick phone call or an email to get you on your way. So we just want to encourage you once again, feel free. I handle most of those myself, so chances are you'll end up speaking with me. But if you have any other questions or anything, I mean, there are a number of capable engineers in our office that can help you with that. So thank you, and I hope you enjoy the rest of the riveting content on this website and on this page. Thank you.